Hi, I'm Raghu and welcome back to another session in the series of programming a Raspberry Pi Pico using Python. Interrupts and IRQ. When we wrote code for the IR sensor, we encountered a new concept called IRQ. Let me now tell you more about this. Before this module, when we wrote any code and we wanted to check the status of a pin, we would use the function pin.value to determine if the pin was in high state or in low state. We did this in a continuous loop under the while true block. So why couldn't we do this for the IR sensor module also? For every iteration, the interpreter would check if there's an obstacle and act accordingly. Well, we could have done it and it would have accomplished the same task that we did with the IRQs. However, handling such events using IRQs is a far more efficient way of doing this, and there are several other advantages. We'll see about this. So what is an interrupt and what is an IRQ? That is, interrupt request. When the processor starts executing, it executes the instructions one by one in a sequential manner. When it sees the while true block, it continuously executes the code in the while block forever. When an interrupt event occurs, in our case, when an obstacle is detected, this can trigger an interrupt. When an interrupt is triggered, it asks the microcontroller to stop execution and handle the code for this interrupt. By doing this, we have several advantages. 1. There is no need for the processor to continuously keep checking if there was an obstacle or not. This kind of continuous checking is called polling. Instead, when there's an obstacle, the IR sensor will immediately tell the processor that there was an obstacle. Think of your doorbell itself. If there was no doorbell, or for that matter, no way for the visitor to tell you that he or she is at the door, then you'd have to periodically go to the door and check if there is somebody. That's polling. Instead, by using a doorbell, the visitor will interrupt you to let you know that he or she is at the door. Because the processor does not have to continuously keep polling, after adding the IRQ handler, you can ask the processor to go to sleep, thus saving power. In safety critical applications, there are certain events that have a very high priority and must be handled even if the processor is working on something else. For example, let's say that the same system has a doorbell and a fire alarm. If there is a fire, then obviously the fire event must be handled before all other events. Even if the processor is in the middle of handling a doorbell event, it should stop and address the fire alarm event. But if the processor is in a while block handling the door obstacle, it has to wait for this block to finish before checking for smoke or fire. By using IRQs, you can assign priorities to IRQs, and based on the priority, the processor will handle the interrupts. Now let's come back to the IRQ in our code. We said ir.irq bracket handler equals IR handle trigger equals pin.irqs underscore falling bar pin.irq underscore rising. MicroPython's pin class has a method called IRQ whose definition is pin.irq bracket handler comma trigger comma priority comma wake comma hard. Handler is the function which will be called when the interrupt is raised. The handler function just takes one argument, which is an object of the pin type. The trigger parameter takes a constant parameter which can be one of the following: IRQ underscore falling, IRQ underscore rising, IRQ underscore low, or IRQ underscore high. IRQ falling means that the handler is called when the pin state moves from high to low. Rising means the other way. IRQ low means the handler will be called after the pin goes to low state, and IRQ underscore high is when the pin goes to high state. You can also use the OR operator, that is the bar operator, to combine different types of trigger. In fact, that's what we've done in our example. We made the IRQ to be called either when the level is rising or it is falling. The parameter priority decides the priority of this interrupt. Higher the value, higher the priority. Now ignore the vague and hard parameters. There are a few rules that you need to follow about IRQ handler functions. IRQ handler functions are called as ISRs or interrupt service routines. 1. Keep the code as short and simple as possible. It should only do the bare minimum amount of task required to handle the event. An ISR should return control to the main loop as quickly as possible. If you expect the task to take more resources, then consider setting a flag variable in the handler. The main program can use this flag and complete the remaining task. Avoid memory allocation. Do not do anything in the ISR that will result in memory allocation, like appending to lists, inserting into dictionaries, etc. Due to this reason, you also cannot create Python objects or use floating point arithmetic in ISRs. 3. When data is shared between the ISR and the main program, consider disabling the interrupts in the main program just before accessing the data and re-enabling them after accessing. 4. Do not do anything in the ISR which may communicate with external devices or network. Any of these communication is highly resource intensive and it is not right to handle them in an ISR. So this also includes print statements. The print statement in a Pico, you're actually using UART communication to communicate with your computer's console. So when you use print statement in an ISR, you're going to land up using a lot of resources. Consider using the schedule function in the MicroPython module to work around some of the above constraints. Hope you enjoyed this session and have got a good understanding of the concepts that we learned here. So let's move on to the next session in this series of programming a Raspberry Pi Pico using Python. So see you soon.